Hello, everyone. We return with another coding stream for the day. That's right, the second one. I coded once already, and now I'm doing it again. Because what better thing to do when you can't sleep than to do some programming? Alright. So, we return back where we left off earlier today. So, we had created, I think we were in the sense. Oh, dang, I missed my streak of always having it on the last thing. We were in the sense class. We created the sense class so that it could, cells could actually sense other objects around them. And we wanted to add a get closest and a filter method. But before I did that, there is something I wanted to do in iHasShape. I noticed we're not really using get X, get Y, get W, get H. We're not really using these. So I was curious as to what all we'd have to change if we deprecated. If I remember how to spell deprecated first. If we deprecated all these. And now we go through and, well. Requires a body. Protected. Never mind. We do use these. We use these to get all of these. Never mind on that. Don't listen to me, guys. I am big smart. Huge smart. Just the biggest smart you'll ever find. Alright, with this hype song, we're going to begin with a get closest method or a filter method. You might be wondering. We're going to go with a filter method first. So we're going to do public sense filter. So we want to return the sense after it's filtered. We're going to go ahead and return this. And before return this, we're going to go through. We're going to get, I guess we already have the linked list of objects. So we can do objects. We're going to create a predicate, a game object. We're going to call it not equals object. And then we're going to create a lambda. And the lambda is going to be not object. Actually, we're going to do object O. Object O. And we are going to, instead of calling this object, we're going to call this O. And call this object, actually. So, we're going to get object dot get class dot, I believe it was instance, is instance of. So, we're going to get, if it's not an instance of the object given, then we are going to, actually, is this a thing? I don't know. Can we do this? T? No. Object. Although we could go see Coding with John and see what he has to say about this. I think that's a good idea. Let's go see Coding with John, shall we? We were last on the lambda expressions. But now I want to go to, we were looking at optionals, and optionals are fine, but generics. Let's see what he has to say about generics.
In this video, we're going to talk all about generics in
Generics in Java. Thank you, John.
Every time you see them with all the T's and question marks and angle brackets and K's and V's. But I promise by the end of this video, you'll know exactly what generics are, why they exist, and why they're useful, and how
Thanks, man.
you can use them in your
All right, I am curious. I know I was already pretty far through this video.
Thing to print equal to the thing to print that was passed in. And we can have one method to actually print this out whenever we want to. So that would be public void print. And all that does is just print out the thing to print to the console. So system.out.println thing to print. So if we wanted to use this integer printer class, we would just create an integer printer equals new integer printer and pass in the integer that we want to print.
Blow my nose real quick while we listen to John.
We want to print out the number 23.
Oh wait, that's not my cursor.
We can call printer.print, and when we run our program, of course, it prints out 23. But what if we wanted to do exactly the same thing for a double instead of an integer? Well, we couldn't
He
use
would
this
create
class,
new
right, because it's
classes,
double. So
a
this
double
is like
printer, a
loop.
string
For
printer.
this, you have to define what is called a type parameter, and you'll put your type parameter in angle brackets like this. By convention in Java, typically you'll see this type parameter just called t, but technically you can call this type parameter whatever you want. But I'm going to just be using t, so you can.
So let me see how he used this.
Of type t. Right now,
Of
as we're
type
coding
T.
this class, we don't know what types of things is going to take in something of type t. So now this class is
So you almost create a new thing entirely.
Type we want. But now how do we actually use this class if we want to, for example, create an integer printer like we had before? Well, back here in our main method, instead of an integer printer, now of course we're going to just create a printer. But now you can see that we have a warning here that printer
Cannot instantiate because you gotta say what it is. Integer,
there again,
then integer, you don't have to do that again.
Printer and the string printer, we can just delete those because now we can use our generic printer class to be able to create printers for doubles and strings also. So now all we have to do if we want to create a printer for doubles, we just say printer and pass in double for equals new print. That can print any type that we give it. Doubles.
So let me see the things he does with it.
Array works fine, but if you try to do cat in the same way, be able to create a list of anything we want, why do we have to deal with all these generics? Why can't we just create like an array of just objects and then we can put whatever we want in it? Well, it is true that you can do that and your code will work, but it won't be type safe at all. Let me show you what I mean. Let's say that our array list, instead of holding cats, just holds objects. This is the kind of thing you'd have to do if generics didn't exist. You'd just have to create an array list that can hold whatever. So in this imaginary world without generics, we still want to create a list of cats. Get stuff off our list and element of the list at index 0. But here we get an error that we have a type mismatch. You can't convert from object of objects. So I can store it in this log. Well, the code all looks the same. There's no compilation errors or exception right here on this line.
Okay, so that's casting.
Now we can as this.
What else does he do? T extends, that's cool.
Serializable interface, you just put in extends, serializable. You might think that because this is an interface, you should put implements. Many things as you want here.
T extends, animal and serializable, interesting.
Shout, since it'll print things out with exclamation points. It'll take in some kind of type that we're going to call T. We'll call it thing to shout. And inside that method, all we're
interesting. Okay, I almost want to look back at the motion thread.
A bunch of exclamation points after it. So right now we're getting an error here because Java is saying, hey, T isn't a type. What do you want me to do with this? To tell Java that this T is supposed to be a generic type.
Here we go. This is what I'm looking for.
Signature right before the return type.
Right before the return type. That's what it is.
Type in angle brackets. Again,
that's what I'm looking for. Cool. All right. Thank you, John. You're always helpful. We love John. Let me turn this back down. Turn it back down for me. So in public sense filter, it's going to be right before sense. We're going to do T for type. T object. There we go. And it could be anything. T extends a game object. Perfect. And then we're going to see if, let's do this real quick. Objects, this dot objects dot remove if not equal, which is our predicate that we've created, and then return this. Beautiful. So now, if we went over to cell, we can now call sensor.filter. Sensor.filter. This. And we put in an object. Let me do what John, see what John did with this. Excuse me. Interesting. Okay. See, this is pretty good. I do want to see, going over to the motion thread, if we can actually get all objects if object is movable. Okay, no, we're probably going to do the same thing here. Or could we perhaps do something like this? For T extends a game object. Is this a thing? I don't think that's a thing. We're not going to worry about that. A game, this already works, and it works pretty quickly, and it works how we want it to work. So we're not gonna play around with it. We are gonna go to the cell though. We can filter this, and then we can do sensor dot no system dot out dot print line sensor dot get sensed objects. Well, I guess we're just gonna get cells anyway, so we'll see what that looks like later. I think. Obviously, they all see a lot of people. So we created our filter method. That's pretty good. But now, which by the way, let me go ahead and change it to 1,000 instead of 10,000. We're going to go over to sets and we're going to add get closest. Public sense. Oh no, public a game object. Yeah, a game object, get closest. All right. And then we're also going to do cell, because we want to get the cell that we're, well, I guess instead of getting a cell, we can get a position, an XY location. Although we've been using position a lot, get pause, so we're going to do position instead. Return null for now. So we're going to want to get distances. So XY closest. And then for a game object, objects. Although we are going to want to get object, new array list, a game object, objects. Perfect. We're going to go through an array list of these. And then we're going to get position. If I'm correct, a distance between 2 points. We're going to look up the math a little bit, cheat a little bit. Distance between 2 points. All right. Wait, what? That's not what I want. We'll look how to get. Oh, the distance formula. Oh boy. I guess it's pretty much the same thing we did earlier. It's we get interesting. Let's go into XY and make this an XY thing. So we're going to fold everything, collapse all. This is all the math stuff. Although we're going to put it after normalized vector. We're going to do we're going to not type public yet. Distance. Public XY distance. Although it's actually going to return. It's probably going to return a float more than anything. And we'll get distance between XY, XY. So you're getting the distance between this XY and another XY. So we're going to get, let's take a peek at this again. So X2, so we're going to do, going to be xy dot x. Although it's really going to... No, we're not going to do xy dot x. xy dot x minus this dot x. And then all that squared. So math dot dot power. No, it's just another monkey. This song is pretty not narcissistic. You know what I mean. It's it jacks itself off a little bit. Sorry, Fat Rat. And then we're gonna get y and y. I cannot type. Y minus y. Both squared. And then we're going to do math dot square root of those two added together plus this one. Is this the distance formula right here? Is that it? Square root between the power between those. Oh. Well, that was easy. That was easy. Although, what does this return as? A double? Fine, we'll use 64 bits, I guess. Excuse me. Excuse me again. Position dot distance. We'll call it distance 2 because that's what we're doing. XY, please. Distance 2. Distance 2. Also, there's something here we're not using. We're going to use object.getPosition. Oh no, get center. Close. I guess it should be a hash map or a map. Let's look at Java hash map. And actually we're gonna go instead of the well, we'll do it, and then Java hash set. Let's take a look here. Java hash map. Create a hash map object. Get England. Okay. Okay. And then hash sets we don't have to worry about. Okay. We are actually, wait. Let's look at hash sets for a second. Hold on. Interesting. Our hash set versus array list versus linked list. And hash set. Well, hash set is array list versus linked list, yeah. Slow for random access due to traversal. Right. Hash map versus hash set. Of course, C values and pairs. Constant time complexity of basic operations like put, get, and remove. Right. On the other, it says information stores unique elements without duplicates. Hash set ensures uniqueness but doesn't maintain order. Is suitable for scenarios requiring fast random access and iteration, but maybe slow for instance. Anyways. Fast access for key-based retrieval and is ideal for mapping keys and hash set is efficient for maintaining unique elements but doesn't preserve order. Interesting. Let's do hash set versus linked list. But does not retain insertion order in the set. We almost want to use hash sets instead of linked lists, guys. Let's do it in find linked list and do hash set. Replace all. What does it change? Nothing. No errors. Let's go to the spawner thread and do the same. Okay. What else calls this? Does this have linked list? It does not. String not found. Logic thread. Spawner thread, painter thread. Window. Cell. Wow. Linked hash set? What? Why are there so many? A linked hash map, okay. Linked list versus hash set performance. Hash set list. Oh. Okay, and I don't think there's anything we'll need to do that's not hash set-esque. Okay, we're using hash sets now, everyone, instead of linked lists. And then we're getting an array lists of stuff for looping. Best performance for loops. Java. Right. Is array list or hash map performance better for loops? A map. I guess it would be a hash map list. Huh. Mm-hmm. Okay, we're not going to worry too much about that. Getting an array list of things seems to function fine. Huh. Get closest. We're going to create a new hash map, and it is going to be a game object double map equals new hash map. And what is a hash map list? Okay, no. So we're gonna do map dot add map dot put. Okay. Excuse me. I'm still a bit sick. Excuse me. All right. Collection values is a collection of doubles. Dot. Excuse me. We're not going to worry too much about that. Is there such thing as just a hash? We want to get the smallest. So for now, we're going to remove that. Remove that. We're going to store int smallest index. Yeah, we don't need to get the distance. We're going to grab this and we're going to do if position.distance2 object.getCenter is less than. We're going to go and make a variable that is double smallest distance. Less than smallest distance. We're going to do smallest distance is equal to position.distance2. There we go. And then smallest index is equal to object.index. No. Objects dot index. No, I want to get this array list. So we're going to make the array list a variable. List equals new. We're going to do this. List. Do list dot index of object. It's not initialized.
You don't understand. Heaven never listens. They didn't listen to me. They won't listen to you.
You don't know that.
I do.
We're just gonna get the first one. Smallest distance equals position dot distance to list dot get. The first one. Dot get center. we're going to do equals 0. So we're going to initialize them initially. Bruh. And then we will return list.get smallest index.
Dad, I don't need you to protect
And in this, we're going to do system.out.println
I didn't really know you.
this dot get position get center dot distance to sensor dot get closest, which is going to be this dot get center. Method distance to
It's the view I had of you that show me dreams can be worth fighting for more than any.
dot get center. There we go. That's complicated, but I just want to be able to test. Oh shoot. Let's just make 2. Okay. Index 0 out of bounds for length 0. Makes sense. Throws. Oh. I don't want to do throws. I don't want it to execute unless I can almost create an annotation for that. This dot get center dot distance 2. Sensor get closest, which is going to be the center. This dot get center dot get center. Oh. Get closer to the center and then get the center of that object. Or yeah, dot get center because I wanted to get the distance to that. We'll call the first one exception and then oh. So we want to make sure that sensor let's try and create an annotation, shall we? New annotation must have not empty. Add a target. The target is going to be method. Yeah. Add retention. Let's look up what is annotation retention. Oh. Add retention runtime. Target is method. Interface not empty. I think we gotta go visit John. Hello, John. And let's go look for John's video on annotations. Because he explained it pretty well. John, where's your annotation video? Why is Java so hard to learn? It's not. I find the other ones are hard to learn now that I know Java. Well, actually, maybe that's a problem with Java. I find the other ones are hard to learn. Java was actually pretty easy to learn. Find prime numbers. Nice. Where's your annotations video? John, did I miss it? I think I missed it. Excuse me. How to use this, bruh. I guess it could tell me where not to use this because I use it everywhere. Annotations.
Annotation.
REST API. Wait, I want to know what that means. I'll learn it later.
Annotations are a really cool and useful part of the Java language. Add
Okay,
one
let's look
concept
here when he made the
Now,
annotation.
the next annotation that you're going to want to add annotations that only we get pass in. Then we can have our program is running using some fancy, but we won't add it to the eat method. What we're going to apply only to methods, we will use that this run exactly like a normal field. So now we can specify this int times parameter when we use this annotation. And then back over here in our main method,
Parameters.
where we're already processing this annotation, getting the value of that times parameter is really easy. So here inside this is applicable to methods. If we did want custom annotation, there are two paths as well. Annotation before it even starts to
Okay, cool. That's all I needed to know. Is what the body was for. Speaking of which, array list question mark. We're going to call this list. Let me go look at how he formatted it. Invalid type array list for the annotation attribute non-empty list. Only primitive types can be used. Okay. List size. We're going to do int list size. So what happens if you were to system, let's do system.out.println, and we're going to try printing. Make a new array list object dot size 0. Cool. So now, if I were to put not empty, sensor, wait, not this. I need to put it on sense. Not empty. Objects dot size. A constant expression. Maybe annotations is not the way then. Maybe we should just add the logic. We're gonna do it right up here. If, can I do this? Return null. If this dot objects dot size is equal to 0. Is not more than 0. If not, objects this dot size is more than 0. So if it's not more than 0, return null. But if you return null, we're gonna have some problems. Null pointer exception. So maybe I create an annotation for that. I almost want to go look at Minecraft's annotations. We're gonna look at these for a quick. Not null. Documented retention. I don't know what documented means. Class. Custom exceptions should be thrown in. Interesting API status. Whoa. 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 Annotations like that are too complex for me. That's what I just now learned. We'll close that up. And let's think. Let's think real hard here. Well, I guess we just need to make sure that this isn't null. Try. Whoops. Catch. No pointer. Exception E. And we're not going to do anything with that. We're doing a system dot out dot print line. Empty. And it's always going to return empty. So this, we're sensor updating this. But they're not close to each other, that's why. Of course. So for testing, we're going to do spawner dot add object. We're going to copy all the new cell stuff. We can't add a null object. That's probably not going to be very nice. We're not going to do new XYs. We're going to do 10, 10. So let's make it at 100, 100. Let's make a new one at 115. And then make another one that's going to be at 120Y, which should be further away. And 110X. And then we're going to do, we're not going to print empty. We're going to do we're obviously going to have to add a logic of if there is no closest, which makes sense. So we will system.out.println sensor.getAll get sensed objects. We're going to do a plus. We're going to do sensor.get sensed sensor.get closest, which is this dot get center. Dot toString plus, and then we're going to do that little string. Okay. Well, since everything is unmoving, we're going to leave it printing for as long as it needs. So we get this. We're also going to add plus. That plus sensor.get closest to this dot get center dot get center. Actually, we'll just get position so it'll match. What the? What is happening here? Okay, let's stop this. That was really interesting. we're going to do this dot get position plus this dot get sensor plus we're going to look here for a little bit. It has two cells, cells D and cells C. Get sensed objects. And then each cell we can do a... We're going to do another thing here. Two string methods. Public string and position. Return this dot to string plus this dot get position pause. Then we'll do get sensed objects dot and. Oh yeah. We can't really do that. Sensor dot get closest. This dot get center. No. Sensor dot get sensed objects dot iterator. O, and then a handler. We do system dot out dot print line. O dot and position. Iterator for cell. Oops. T extends cell. Cell C. Change to list iterator. Okay, why am I forgetting how iterators work? I literally just use these. We're gonna go over here. We're gonna see iterator for each remaining. I am big smart. Dot for each remaining. It's not a field. There we go. We're going to attempt to cast it to cell. Is that a thing we can do there? We're just trying to do debugging here. Oh, that's why I didn't add the little brackets at the end. That's on me.
Any last words? All I gotta do is open this bag.
I saw an error there. I didn't see an error there. Okay. Sensor.get sensed objects. Dot iterator. Dot for each remaining. And it should be printing this. We're going to do this outside of the try. Okay. All right. We're certainly having a time here. For each remaining. We're not going to print this. Oh, there's one still going. That's why I'm confused. There we go. This dot to string plus. Okay, so first, from cell 45, we see that we have cell D and cell 5 at 115 and 110. Or at 100, 115 and 100, 100. Okay, so then we get, this is cell 45 at 110, 120. We get cell D as its closest, which would be correct. And then from cell D, we get the 110, 120, and the 100, 100. It should be closer to 100, 100, I think. Yeah, look at that. Okay, so it is working. So we're going to get this dot get center, again, distance to, we're just going to use it center dot get closest. This dot target equals, then we're going to get center. Actually, get pause, so they don't dance. Sensor get closest. Look at that. So if I were to create, I don't know, a bunch of them, like 2,000 of them, any that are sensing each other will want to go to their closest ones. Look at that. And they're so confused on how to get there. It's so cute. Good as so. Okay. So now that we have that, we're going to go back to only 1,000 of them. Now that we have the ability to get closest, I want to create something it'll automatically test, and if something doesn't happen, it'll throw. I could just, I could at least make sure that in sense, getting closest does throws index out of bounds exception. Oh. Null pointer exception as well. Sets are not getting closest. But I want it to throws like it can't do anything. Well, you know who we have? We have John. We're going to fully watch one of John's videos here. I'm going to turn the audio up for John.
Today we're going to talk all about. Hey guys, John
No!
here. How's it going? Today we're going to talk all about exception handling in Java.
Exception
We're going to be going
handling
over
in Java.
what exceptions are, how you can handle them with what's called try-catch blocks of code, what happens when you don't catch them right away, some different types of exceptions and what's called the exception hierarchy, and finally we're going to learn about finally blocks and what they are and what they do, and some super crazy unexpected results.
He looks like he just came out of prison.
Don't
Got the prison
understand
fit going
what
on.
finally blocks do exactly. So you're definitely going to want to stick around and check that out. But first, what is an exception? An exception is a generally unwanted event that interrupts the normal flow of your program. So here's a quick example of some simple code that would cause an exception. We were trying to parse an int from the string pants. You might be familiar with this integer parse int method. It just takes a string that you pass in that usually contains a number like 1 or whatever, some kind of a number that's parsable into an int.
You're
but
so
here we're
cute, John.
trying to parse the int pants. Let's go ahead and run it. We can see we get this number format exception because it can't make a number out of pants. Now, trust me, try as you might, you can't make a number from pants. It just has to blow up and throw an
two legs.
exception. I can't do what you
One
want.
pair of pants.
If you, the programmer, don't handle the situation, your program blows up, prints some exception information to the console here that we're looking at, and terminates. That's it, game over. But now that is where
That's interesting. ADHD tangent. You can have a pair of shoes or a pair of socks, and that's correct. That is a pair. It is two. But a pair of pants? Or underwear? A pair of underwear? That's not two things. It's not a pair. It's like a pant. Huh. English is strange.
where exception handling comes in. So instead of just blowing up and terminating the program, you can catch the exception that's thrown and have special code to handle that situation elegantly instead of blowing up. In Java, we do
Makes
that
sense.
with try-catch code blocks, and they look like this. And first, you have a try block, and inside the curly brackets here, you write any code that you want that might cause an exception in some situations. And then underneath that, you have a catch block to catch those types of exceptions, and then write any code that you want to execute whenever that type of exception happens. Going back to our pants example from before, we can go ahead and paste in the code that causes the exception to be thrown in this try block here. So of course, same as before, this piece of code will throw a number format exception when we try to parse pants into an integer. So we include this catch block that says we will catch a number format exception if it is thrown in the try block. Get it? Throw an exception, catch an exception. It honestly took me way too long into programming to make that connection. So in our example, when this number format exception is thrown, the code inside of our catch block will execute and the program won't have to terminate. Here so far we don't have any code in our catch block, so let's go ahead and add some. Well, basic thing you might want to do is print out a message to the user. You might want it to say something like, hey dude, you can't make an int out of that. Stop trying to make it happen. All right, so now when our program tries to parse an int from pants, it'll throw an exception that our catch block will catch, and we'll see the statement print out. Let's go ahead and run that. And here we see the printout, but the program didn't terminate. We don't see the big angry stack trace of the exception that we saw last time. Also, it's important to note that if an exception is not thrown, this catch block will never be executed. So if we go ahead and change this to a normal int string of 1, we can go ahead and run our program again. And we can see we got no output at all. The program just finished. We can add a little statement here at the end just to prove that the code is actually running. And here, run the program again. You can see that we finished the program, but we never executed this catch block because there was no exception thrown. There was no problem, so there was nothing that had to catch the exception and handle it. Now, it's important to note that the catch block here, this type of exception in your catch block, uses something called the exception hierarchy. And that just means that the type of exception that you put in your catch block will catch only exceptions of that type or any subclass of that exception. So as a quick example, you'll often see just catch exception E. And you can name this exception variable that it catches anything you want. Often the convention is just to use like the initials of the type of exception that you're handling. That's why number format exception was NFE. And for exception, you'll see exception E. So this means it will catch any type of exception at all. Any class of exception that extends from exception, and all of them do, this will catch all exceptions. And the way we had it before, number format exception will catch all types of number format exceptions. There could be subclasses of number format exceptions for specific types. This would catch all of those underneath that umbrella. And taking a quick look out at the documentation for a number format exception, we can see the hierarchy that it comes from. So of course, object is the parent of every single class in Java, and then underneath that we have throwables, and then right underneath that, exception. And every type of exception in Java is going to be underneath that. And a few steps down, we find the number format exception. One of my favorite terms in programming comes from this. When you're catching every type of exception here, I've heard it called Pokemon exception handling. Gotta
I
catch
thought he
them
was going to go
all. And
catch
you may have
them.
noticed from this class hierarchy here, there's also these throwables. So it's important to note that there are actually two types of throwables. There are exceptions that we're going to talk about here, and also errors. Generally, you don't want to be catching errors. So you might see some programmers saying catch throwable T here instead of exception E.
But that's scary.
And that's generally not recommended. You don't want to be catching just all throwables because you don't want to catch errors. You just want to catch exceptions. It's enough to say it could just cause some really strange, unexpected behaviors. Now, in your programs, you don't necessarily need to catch your exception right at the exact line that it happens. When an exception gets thrown and it's not caught immediately in the method that it's in right then, it'll get thrown up to the method that called it. That's called the call stack. Thrown exception goes up the call stack until it is caught by a catch statement like this. So for example, if we had all of this code and it was in a method just called like get int or something. But right now we have our try catch in that method, but we don't have to. Often it makes sense to have your try catch in the method that calls the method that's throwing the exception. We could refactor it to look like this. So what happens here is when this line throws a number format exception and it's not caught immediately in this method, it gets thrown up the call stack. That just means it's thrown to the method that called this method. And in here, it's thrown back up to this level in the main method. And here we have a try catch. So it's going to get thrown out to this level of the call stack and caught by this exception handling code here. So let's go ahead and run it.
That makes sense.
Our exception handling still worked. We still got the hey dude comment, and the code ended with no explosions of an exception. No stack trace printed out to the console. Another cool thing to note is you can catch multiple types of exceptions with multiple catch blocks. So you might have your first catch be for like a number format exception, and then you could have another block, just copy that and paste it, to catch a, like say maybe a null pointer exception. This allows us to have different behavior depending on the type of exception that was thrown. Say you want to catch different types of exceptions, you just want one bit of code to be able to handle multiple different types of exceptions. Well, you're in luck. Ever since Java 7, you can have what's called a multi-catch statement. And to code one of those, we can just get rid of our second catch statement, just have number format exception, And then to denote the multiple types of exceptions you want to catch here in this block, use a bar character, the same character you would use for OR statements, number format
but a
exception,
single one.
or null pointer exception, and run the same exception handling code in either case. And that way you avoid code duplication while still being able to catch multiple types of exceptions. Pretty cool. Finally, let's talk about
Thanks,
finally
John.
blocks. So if you want, you can include a finally block after your catch block. That'll look like this. Look very similar, just finally this. All this block does is to contain code that you want to execute whether there was an exception or not. It will always execute. Always, always, always. So just as an example,
add it right
let's go ahead and put, let's see.
Like the end here.
The finally block. Right here.
In the finally block.
So we can see when the finally block is executed. Just to make things simple, we're going to get rid of our extra method here and just put this statement that causes the exception directly in this try block. Now what'll happen is this pants parsing will again throw an exception, a number format exception. So we'll just get rid of this null pointer exception catching. So this
is
will
this
catch
just
the
how to
number
use try
format
catch?
exception. You can see we caught the exception.
Excuse me.
It's thrown here and out to this catch statement. So anyway, getting back to our finally, after it ran what was in the try, which threw an exception, ran what was in the catch, it finally ran what was in finally. And it will execute that whether there's an exception or not. So we can change this back to a 1, so an exception will not be thrown, run our program, and now we see this catch block was not executed. But we have, after parsing pants, this didn't throw an exception, so it could print this statement. And then the catch code never executed because there was never an exception thrown, but it still executed the finally code, no matter what. Now, when I say no matter what, I mean no matter what. You can literally have a return statement here in your try. You would think that after this code executes and you get to return, it would just return out of this method and not execute anything else, but it will always execute your finally block.
Oh,
See?
okay, that's cool.
Even though you have a return statement
I
here
like
after
that
parsing pants, it still runs your finally. And here's an even weirder example of the same thing. What we have is a simple private method that just returns an int called print a number. And all we've got here is a try catch finally statement, where in the try statement we say return 3. In the catch statement we say return 4. And in the finally statement we say return 5. So of course what's in this try block won't cause any exceptions, so the catch block should never get called. But in the try block we're saying return 3, and in the finally block we're saying return 5.
Okay.
In our main method, all we're doing is printing out the
I'm on the
result
edge of my
of this
seat.
method call. So let me know, what do you think the result of this method should be? The answer
5.
is 5.
Yay.
Remember, what I was saying is the finally
Finally
code
always gets called.
always
I thought it was going to
executes.
maybe do it twice.
And that means that a return statement in your finally will override a return statement
That's cool.
in your try.
I'll bet
or-
that has a use.
So there's certain special.
Custom
So
exceptions.
you want to create your own custom exception in Java, but how exactly do you do it? We'll walk through the process of creating custom exceptions in detail in this video. It's way easier.
Although also checked versus unchecked.
You've probably
Let's
heard
take a
people
peek
talking
here.
about checked and unchecked exceptions in Java. But what does that mean? What exactly is the difference between a checked and an unchecked exception? And what do you need to know about how to handle each of those types of exceptions in your Java programs? We'll cover all of that with some concrete coding examples in this video. My name's John. I'm a lead Java software engineer, and I love sharing what I've learned with you in a clear and understandable way. I also have a full Java course available and a link between a checked and an unchecked exception. Well, a checked exception is one that is checked for at compile time. But what exactly does that mean? Well, let's talk about it with an example. Let's say we have a method in our program where we want to just read from a file.
Excuse me.
So one way we could do that is private static void read file, and it takes in a string called file name. And one way to read from a file is using a file
Okay, we're
in
gonna
the
skip-
file name
skip through this a
that
little
we
bit.
want to open. And we can call this read file method from our main method here just by doing read file and passing in the name of the file that we want. Let's just say it's called myfile.txt. But as you can see here, Eclipse is giving us an error. It says unhandled exception type file not found exception. So what's happening here is when we try to create this file reader it could throw an exception. If the name of the file that we pass in doesn't actually exist, it could throw a file not found exception. And Java is giving us an error here and telling us that we need to deal with the possibility of this file not found exception happening when this piece of code is called. And that is because a file not found exception is a checked exception. Checked exceptions are exceptions that Java makes you deal with one way or another at compile time. That means that before your program will even compile successfully, Java
Is this a
and it
10-minute
won't
video to
compile
explain
until
this?
you do. So right now, if we try to run this program, we can't
Maybe there's cool
because we
uses.
still have a compilation error. This error is blocking us from even compiling our code. If the file not found exception was an unchecked exception, we wouldn't be seeing this error here. We'll talk more about unchecked exceptions a bit later in the video. So how do we deal with this error that
Okay, you do the try catch.
here, then your code you make exists. File does not. Instead of try catch, you can just tell Java, yep, I totally understand that this, so I'm just going to declare to you, Java, that I could throw it, and whatever piece of you just put a throws declaration right here in the method signature, right before. All right, so great. Now we no longer have that error here in our code that we had before, but now we actually have an error here where we're calling our read file method, and it's the exact same error, unhandled exception type file not found exception. What happened is that now if that file not found exception is thrown, there's nothing in this method to catch that exception. So that exception will just get thrown from this.
So it's still any check
It's
always
a
has to be handled
possibility of
somewhere.
Doesn't cause another error like it is the main method at the very top of our program. Once that
Yeah,
exception gets
okay.
thrown up past your main method, your program just dies right there immediately, and all you'll see is a stack trace output for that exception. All we did was tell Java, hey, I'm going to throw that exception. We didn't have anything that actually dealt with it. So our program had a much exception
makes
by
sense.
using a try-catch block or declaring that you throw it in your method signature. And that is not the case for unchecked exceptions. So what does it look like with unchecked exceptions? Let's say we just had a method like this one here that just takes in a string, we'll call it my string, and all it does is just print out the length of that string. So it prints out a name, passers, but what equal to null length method. Then when it tries to take that parameter and call the length method on it, of course we do see that it gets a null pointer exception. So obviously we have a case here where this method could throw a null pointer exception, right? But Java doesn't give us any compilation errors here. It compiles fine and then only explodes when we actually run it. And that is all because null
is an
pointer
unchecked
exception
exception.
is an unchecked. The difference between checked and unchecked exceptions. That doesn't mean you can't do those things though. If you want to, you can absolutely put, and you also absolutely can add a try catch around this phone and can get permanent exception hierarchy. Java's exception class is a subclass of throwable. Error is the other subclass of throwable. Errors are separate from exceptions. They're usually for things that can't be recovered from, like out of memory error, stack overflow error, things like that. So it's a bit outside the scope of this video. Anyway, all
Okay.
we get that compile time error, unhandled exception type exception, and we have to deal with it for our program to compile. But if instead of throwing an exception, we throw a runtime exception, now we don't have any compilation errors at all. And that's because
Interesting.
exception is a checked exception and runtime exception
Is unchecked.
difference is just that Java doesn't
Cool. Now let's look at custom exceptions real quick.
easier
And
than
then
you
after
might
this,
think.
I think I
And
know
we'll
what to
also
do.
talk about how you can make those kind of mailgun for to use
Ooh, sponsorship.
Wikipedia.com/John. Now let's get to it.
Also,
Okay,
I
so
need to be
creating
liking
your
these
own
videos.
custom
I like
exceptions.
John.
How do you do it?
You're beautiful,
well,
John.
let's start with a quick example of a situation where you might actually want to create your own custom exception.
He has a shiny head.
So let's
and
say
I like
we
it.
had a method that all it does is take in an int that represents an age, and all it has to do is validate that that is a valid age. So that would look something like private static void, we'll call it validate age, and all that would take in is an int age. Okay, and then up here in our main method, we can call this validate age method with whatever int we want. Let's just say 3. Now, one reasonable validation we might want to use in this method is just validating that this age is not negative, because a negative age doesn't make any sense. So we can just say if age is less than 0, then what we want to do is throw some type of exception that this is an invalid age. Now there are tons of different types of exceptions that are already built into Java. And if we wanted, we could always just throw a generic exception. And some built-in exceptions might get pretty close to the type of exception that we want to throw, but what you might want to do is create your very own exception to match this exact situation. So, how exactly do you do that? Well, the first thing that you need to do is create a new class. So over here, class will be our new exception type. Good to be as you do. But if we go back to our method here and try to throw a new age less than 0 exception, we get an error. And that's because to declaration,
it is
the
not
error
it
is
needs
gone,
to extend.
but we have a new exception. So now if we go back here, that error is gone, but we have a new one. So what this error is saying is that, hey, I know here that you're throwing this exception, so you either need to surround it with a try catch and deal with the exception, or declare up here in the method signature that this method can throw that exception. For now, we'll just go ahead and add it to our method signature here, and we can use it. Where we're calling this method, we're going to have to do the same thing. So let's go ahead and click the we don't check. Now we'll go ahead and keep our exception. Here we go. Now, age less than 0 exception. So now, of course, if we go ahead and run our program, since we're sending in a valid positive age of 3, we don't get any exceptions.
Yay.
But if we change this to something like -1 and run it again, we can see that we get this age less than 0 exception that we made ourselves. Pretty cool. So really, that's how you can get a basic bare bones version of a custom exception. Literally the only
But then he's going to add stuff.
In some message where we run it, we have to change these throws declarations to now if we try to do the same thing, this string message along with it. But now if we try to do the same thing with our own custom exception that we created, so maybe in that case the message can be age cannot exception class doesn't have any constructors in class. That
okay, so you create a constructor
as of the custom string message that while looking before you're set off any constructors at all, then Java won't provide that default constructor for you. So once you've provided any other exception and just an open and close parentheses, because this
like
doesn't
an
take in any
abstract
parameters,
method then,
and you don't even need a
exception.
message body. So you can just open and close curly brace. Constructor, all we have to do exception, and then as a parameter, it takes in a throwable, and that throwable is called cause. And then inside the constructor, all we have to do is call the exception class's version of the same constructor, again, by just calling super, used by some other exception. Now when the throwable exception into you run your code, it will show the cause.
Okay.
It prints out the message, another extend oh no, along with the cause. That is technically yes, but don't. Again, if you do, I will find out. But now, why exactly is that? Why is it a bad idea to extend throwable or error?
Because throwable can
also
also be an error.
With generic separate from exceptions, and they usually indicate a serious problem that you should never try to catch and deal with, like an out-of-memory error, a stack overflow error, things like that. So you can create your own. The types of a method has been into this method. It's probably this video Java 2 more than 30.
Now I'm curious if I were to, let's go to the middle monitor again, return our music. If I were to create a new class exception test extends exception. Oh, did they add this? Oh, no, it's just a thing. At unchecked. Is that a thing? No. Unchecked exception? Oh no, runtime exceptions. That makes it unchecked. Cool, okay, I don't have to worry about that. Don't save, delete exception checked. Okay. So first and foremost, we know that if there's no we know that we're not going to want to call this. Oh, whoops. we're not going to want to call any of this if this is empty. So right out the gate in copy this, we're going to do if sensor.get sense objects. Actually, even better, we're going to go to the sensor. I'm going to do public boolean is empty. And we're just going to return this dot object dot is empty. That's all we would also want. Private. There we go. Sensor dot is empty. There we go. If the sensor is empty. Ta-da! That's done. Sensor dot is empty. Oh, also is not empty as well. Is not empty. Is empty. So we're going to turn not this object is empty. Is not empty. So if it is not empty, then we'll execute. Oh shoot. This dot target equals sensor dot get closest. I'm going to do this dot get center. Dot get position. So now, as long as it's not empty, then it'll try and get to the closest. All these guys cannot sense anybody. So if we were to go into, if we set like the site to 1,000 pixels, everybody's gonna find a friend, no matter where they are. I don't know. But they're just gonna switch positions like that. That's so if reaction time is 100, which by the way I have a to-do there. It was something I found on my own. There you guys go. Nice. We want to make sure that speed does not cap at 120 so that it can move even if it's above, like, if it's above 120, say 200. So right now if it's above 120, it's just going to move once a frame. So I want to go over to move. And it's going to set velocities. So to target. So to target sets the velocity to a vector towards something which normalizes to 1. We almost want to do private to target velocity remainder, and it's going to be a float. And you know what? We're going to change all the floats to doubles because we like doubles. Why not go 64 bit, you know? So, to target velocity remainder is going to be equal to nothing. And then, and figure out what the remainder is. To target the velocity remainder. So this dot to target velocity remainder will be equal to some right now we'll call it 0. And then vector normalizes vector. We want to be sure that if the speed is more than 120, we're going to multiply by that. So this dot speed divided by 120. But we want to do math dot max get the max value of just a speed of 20, and then normalize this vector. Dot. So we're going to want to create into y. We already have an add. And subtract, which I want to go ahead and create that. Real quick. We're going to go over here and create public xy multiply. And we're going to create 2 of these. And we're going to return this, int multiply, and we're going to do xy xy as well, and I guess xy came first. Add, subtract, multiply, which is going to do the same thing. Is this a thing? Multiply is equals? I guess so. It equals itself multiplied by multiply. Times equals. Let me make sure times equals, yeah, 1 times 2 equals 2, and then set it to such. So now we're going to take this and do dot multiply. Is not applicable for arguments double, which is, oh, that's right. Oh, that's right. That's right, because our velocity is calculated in integers. That's right. It's going to multiply by this, by the math round of this value, math dot round. Gotta add that. So we're going to round this. It should be returning an integer. What? That's okay. I almost want to create, in that case, you can put in any number, and it will cast it to an integer. No, not cast. Okay. Math.round. Float turns into, okay. Turn doubles into floats again. I was right. I was right about floats. Okay. So get the max of the speed or just the tick rate. And we're going to round it by this amount. Divided by main dot tick rate. So this is going to probably just return 1, right? Let's go ahead and see. Everything should be moving at normal speeds.
Tell me you did not know that would happen. Say you didn't know how that would end. Look me in the eyes and tell me, Captain, that you did not just sacrifice 6 men.
10.
Use your wits to try and say I'm crazy and mad. That this is
We're going to see what it looks like when we set speed to 120.
Tell me you did not miss home so painfully bad that you gave up the lives of 6 of our friends.
And then if we set it to
When we fought the Cyclops,
40,
you were quick to hatch a plan.
should be
And
twice as
when we
fast.
fought with Cersei, it was
It's
you
not
who
twice
left
as
behind
fast.
no man. But when we saw this
Multiply, math out
monster, we
rounds.
didn't take a stand. We just ran. Say something! I can't!
This big ass value.
Then you have forced my hand.
Lower your weapon.
No can do. You miss your wife so bad you drained the lives of your own crew.
Don't make me fight you, brother. You know you'd have done the same.
If you want all the power,
It's
you
much
must
worse.
carry all the blame. Odysseus. There is no price he won't pay.
If the maximum value, we're getting the maximum value between this dot speed divided by tick rate and just the tick rate,
My brothers.
and then dividing that by the tick rate. So divided. This dot speed by the tick rate.
Time has come, your luck's run out. Now the time has come to shut you down. You relied on wit, and then we died on it. Whoa.
Let's just do this because I put the division afterwards. That's the problem. It can't be before and after. Otherwise, it's always going to return just those two.
Where are we?
That's better.
Some
Wait for the
island,
lag. It's going to clear out.
the
That.
first one we found.
And try
It's
it.
bursting with cows.
Boom,
Just
120.
roaming around begging us to eat. So
Now we
much
want to
meat,
make sure that
and
the velocity
hunger
remainder
is so heavy.
is going to be equal to.
This statue, the god of the sun,
Here's where
don't know where it's
spicy.
from, but here's where we found all these cows.
To target velocity remainder.
Right in front, and hunger is so heavy. Hunger is so heavy.
It's going to round all this. And then we're also going to get this.
Odie, we're
Math.
never gonna get to make it home. You know
I guess it's rounding it all anyway.
You don't
Plus
know
the tick
that's
rate.
true. This is the home of the sun god.
I'm
Plus.
starving, my friend.
But if you kill his cattle, who knows what he'll
To
send.
target
This is the
velocity
home
remainder.
of the sun god.
Tired, my
Which
friend.
shouldn't do
When
much,
we're
but what
so
happens
close
if
to
we add 0.5?
home, this can't be where it ends.
Yeah.
How much longer must I suffer
Please
now?
don't do
Should I be a little bit
Much
faster?
longer must I push
I
through
need to
doubt?
get
How much longer must I go about my life like this when people die like this?
Nice.
Whoa,
Set
how
to 2.
much longer must we
Incredibly
suffer
fast.
now?
Consider
Much longer must we push through
we can
doubt?
get
It's basically doing this reaction price thing.
Like this
The
when
moon
people
trials.
die like this. Oh, man.
really gets no!
Give me like a no. No, you've doomed us. You've doomed us. You've doomed us all.
You've doomed us all, Eurylochus!
Captain?
Right, move tries. I just changed the foot.
We need to get away from this island now! Grab an arm with all the strength your arms allow!
Okay.
These cows were immortal.
Forget
They were the sun god's friends. And now that we've pissed them off, who do you think you'll
Target
send?
velocity remainder is cool.
Full speed ahead. Full speed ahead. Faster! Full speed ahead. Faster! Full speed ahead.
A non-rounded value.
We're too late.
Of this. Oh, nice. It's Grim who's come to kill you. So it should be correct. There we go. It's going to turn. And then we're going to do system dot out dot print line of to target velocity remainder. I'm going to set it to 121, highway 121. And we're just going to create one cell. We're going to see what that looks like. Well, it didn't create one cell because we have these guys. Interesting. If sensor is not empty. That's right. I'm just going to have to set this. Two target velocity remainder needs to be 1 minus all this. Plus 2 target velocity remainder. So it should add up to 1. Maybe not 1 minus. Okay, never mind. 1 minus this value plus the 2 target velocity remainder. Okay, and again it's negative. Because it's 1 minus, not minus 1. Minus 1. And then if it is equal to 1, if 2 target velocity remainder is more than 1, then else we're going to do this. But if it's more than 1, we're going to set this dot 2 target velocity remainder minus minus. We're going to decrement it. No. Math dot floor. Again, math.round should be all of this. Okay. 2 target velocity remainder. Private int add velocity. Add velocity. If it is more than 1, we're going to do this dot add velocity plus plus actually is equal to 1. And then at the end we set no. This dot add velocity equals 0. We're going to print plus and then plus 2 velocity. And then add velocity. Now if we set it to like 140, let's look at 120. Now let's try 160. Now let's try 200. don't think this is the best way forward. Because again, it's kind of jumpy when it does this. I don't think Speed will ever get this fast, but I just want to make sure that it can.
It won't.
Blue water.
It do water.
That might be copyrighted, but that's fine. We are going to, for now, there will be a max speed. Although we can go higher than 240, I don't believe 180 will be much. I guess 150 won't be much. Between that and 120. Unless we make the velocities double. So for now, speed will cap at 120. So we're gonna have to do it for now. Alright. So we're gonna go and set this back. Which shouldn't do anything since there's nothing nearby. So now we have some of our logic. We're gonna leave that behind for now. And we're gonna do some logic here. If the sensor is not empty, or sorry, if the sensor is empty instead, then we're gonna set it. Wander is going to set a location random just around it within twice its sight range. Actually, Wander's just going to set an effector. This dot velocity equals vec. Is there exactly a respective variable? I made it. New xy dot random. This is going to be 0, 1. I guess 0, 2 since that's exclusive. And 0, 2. So now this little guy should just wander in random directions. He's not wandering in random directions, which is fine. Min-max, min-max. If I'm correct, that's right. Is it inclusive when I call random? It is inclusive when I call random. So between 0 and 1 each. Actually, between -1 and 1 each. This stuff doesn't. Yo! Min-max, did I turn my mic up? Oh, damn. I could just talk closer to it as well. Again, it's actually a really good mic. I just always talk away from it for some reason. Yeah. So you might be confused, Evan, but what I'm doing here is I'm creating, well, I'll go ahead and I'll set the cell count to 1,000. Again, I am creating a bunch of cells. Oh, whoops, their speed is still very high. A bunch of cells We're not going to set the target to another cell for now. A bunch of cells that will basically... I'm simulating natural selection is what I'm doing. They're going to have mutations that can add a little more speed or a little more sight range or a little more reaction time. These mutable properties. And I'm doing it all in Java. That's an old project I did on Unreal Engine, and I just wanted to code it from scratch myself. Hell yeah. Right now, I'm trying to make them wander in random directions. Whenever, I guess. Java for the real ones. Yeah, RuneScape. I forgot that was in Java. We are going to go over to move. And we're going to see if move tries is more 1. And then we're also going to do and this dot velocity is not equal to null. So as long as this velocity isn't null. Okay, so far it's doing nothing. Based ass song, but I'm gonna change it. I'm gonna change it again. Alright, this works. So we're gonna see, we're calling if it gets... Here's what I'm gonna do. I'm gonna destroy this for now, and I'm just gonna set it to XY is gonna be 1x, 0y. So it should just move all to the right, but it's not. Why? That's a good question. Are we calling this? System.out.println called. To do a little testing there, I don't want to make that mistake again. Should be calling called a bunch of times. It is not calling called a bunch of times. Sensor.update this, and then it should be calling this as well. But it's not. If sensor is not empty, but if else, it should be calling this, but it's not. So it should all be, yeah, that's being called. But for some reason, this is where it's going to be based off, I'm going to make like little trees that grow fruits, and then they can go eat the fruits, and then when they eat the fruits, they can, if they eat enough fruits, because I'm also going to make it, the larger they grow, the more fruits they need to eat, but if they eat enough fruits, they will split into another cell, and that other cell might have a chance to mutate a new organelle that'll increase its speed or its sight or whatnot. Why isn't this being called? Sensor, if sensor is not empty. Not empty, I guess. Oh, is it not? Is it? Oh, it's not empty. Oh, I set their sight to 1,000. That's my fault. Pretty much just a fun side project. This isn't for saving Pluto yet. Just kidding, it's not for saving Pluto. This is just a little side project I'm working on. That's personal. We're going to have our own videos for that on the Western Sunset channel, which is going to be pretty cool. I'm doing VODs of this one. Oh, they were fast. They were fast. That was, what was that? I don't like that. That scares me. Because the new XY should be 0, 0 at first, and then call random. What's that about, guys? Is it because I'm calling logic thread and then motion thread? Let's call motion thread and then logic thread. No, they still jump. Is it because of the sleeps? No sleeping allowed. Odd. We're gonna call the sleeps again. They just like me for real. Okay, so now they're wandering. They just change direction every now and then. Randomly. Which is fine. I think I'm gonna do it a little different. Like add bias to where they might not change direction. I need to figure out why they're moving so fast. So quick. This dot velocity should equal nothing at first. Honestly, this dot velocity needs to equal something right away. It needs to be equal to a new xy value of 0, 0. And then they should have 0 velocity. And then there it goes. Okay. So I really just fixed a lot of issues by setting velocity to 0 by default. So now they'll just wander around a little bit. Not a care in the world. Yep, not a care in the world, but I want to add this dot velocity to random. I can add it to the logic thread. No, try react. It'll react if sensor's not empty. Then we'll get we'll say if we're not gonna get if yet. We're gonna do it's gonna get a random direction, but then we could. Well, what happens if we set the speed to like 120? Let's see how they run at 120. Whee! They cover a lot more ground, and some of them decide to stay still. We're gonna say we're gonna create a private void wander method, and we're gonna call wander. It became a actually, wait, check this out. I could do if I remove the random, and I just always set the velocity to 1, and then I'll set their speed to 100. They'll just go, and then you can wait for them to hit the corner. They don't bounce, but you can just wait for them to almost hit the corner perfectly. They do shift a little bit every time on purpose because it's an uneven screen. And so eventually, this guy's oh no, he's not gonna make it. He's not gonna make it. This guy, I don't think he's gonna make it. This guy looks promising. This guy looks really promising. Oh no, he didn't make it. So they're gonna be pretty high up. This guy's gonna make it. Oh no, he's not gonna make it. Oh. Little Russian can dream. He ain't gonna make it though. He ain't gonna make it. Which is why we make 1,000 of them. And check it out. Boom, there's a few perfect ones. Oh, that's right. Because some of them can actually detect the others. Oh, which means all of them should stop at some point. Right? Oh, but I didn't call anything like that. If we do wander, we're always going to call this dot wander. So now they'll all just, boom, there we go. Now we're getting plenty of perfect ones here, yeah. Whoa, that's interesting. Creates a plus. Is that a bad thing? It could be a bad thing, but it's not like that's not the purpose of the program, so it's beautiful. You know, if you do it with 10,000. Oh. They all gotta get going. Almost all of them are going. There they are. They're all going. It takes them a second. That's interesting. JFC. Finger looking good. Head splitting good even. JFK. Oh no. Horrible. It did look cool actually. I think I like that it takes a second. Basically going through, I think it's the logic thread. I'm making it this program multi-threaded. I'm putting everything on a different thread, which is, I made this project once on my own, and I'm like, I want to multi-thread it so it actually runs smoothly no matter how many cells you put, and that's what this is. So the logic looks like it takes a bit, which is fine. I'm watching that again though. That was cool. It's like rain.
It's me
You gotta get curtains of
What
it.
if I'm a
Oh
monster?
yeah.
What if I'm in the wrong?
Okay.
What
So I'm gonna make
if
100 of these guys.
been hiding
I'm gonna remove wander from the sensor not empty, but I'm not gonna do anything to sensor not empty yet.
every time I cave to guilt? What if I've been far too kind to force, but a monster
Okay,
to
so
myself?
wander. You basically want to create a wander bias.
Is the Cyclops struck with guilt when he kills? Is he up in the middle of the night? Or does
Wander
he
bias
end
we don't
by
need, right?
men to
We're gonna
avenge his
create
friend and
a-
then sleep knowing he has done right?
We're gonna
When
create
the
a
witch turns men to pigs to protect her nymphs, is she going insane? Or did
float
she
value.
learn to be colder when she
Let's
got
create an
older
int
and
value
now she saves them the pain?
wander
When a
bias.
god comes down and makes a flea drown, is he scared that he's doing something wrong?
And we are gonna wanna
Or does
input
he keep us
random-
in check, so we must respect
Are we
him,
gonna
and
wanna
now
input
no one
random?
dares to piss him off. Does a soldier use a wooden horse to kill sleeping
Do we want
Trojans
to do this
'cause he is
randomly, or do we want to just
vile? Or
add a
does he
delay
throw away
to
his
everybody's
remorse and save more lives
wander
with guile? If I became the monster,
method? I think I like having a wander bias.
would that make
So we're gonna go up here.
Would it keep our
Well,
foes at bay?
even better, we're gonna go to the logic thread and create
Monster to everyone but us.
a
And made sure we got home again. Who would care if we're unjust? If I became the ruthlessness is
cell try
mercy
react
upon ourselves.
and cell dot.
And deep down I know this well. I lost my best friend. I lost my
Get all
mentor, my
cells.
mom, 500 men
Try
gone. This
react
can't go
is
on.
going to
I must
be-
get to see
going to
Penelope
return-
and Telemachus. So if we must sail through dangerous oceans and beaches, I'll go where Poseidon
I
won't
almost wanna
reach us.
return a
And if I
value
gotta drop another infant from a wall in an instant so we all
based
don't die,
on
then I'll
like an
become
enumerator
the
that says, okay, here's how it
monster.
reacted.
Feel the blow.
But I think for now we're gonna call it a boolean. Oh no, we're not gonna do a boolean. Because then it calls react over here, which is gonna also have to return a boolean. I think the best way to do this is gonna be creating our random wander random. I don't want to create a random for all of them. So we're gonna create a random in main. Or in logic. We're gonna create the random in main. Random equals new random. And then wander bias equals main. Well, actually, we gotta do public static final random equals new random. Main dot random. Main dot random dot next int between 0 and 100. We're gonna make it a, you know, in good old D&D fashion, we'll make it a 0 and 20 chance, and we're gonna do 21 so that it actually gets numbers between 1 and 20. And then I keep spelling wander random, and we're going to create final int private final int wander bias equals main dot random dot next int, and it'll be anywhere between 15 and 19 or 18. So we're going to put in 19 so it includes 18. And then if wander random is more than or equal to wander bias. Wander bias is actually going to be like that. So it's final. Wait, but it's not static. Wander bias. then we're going to reset the velocity. So we're going to system.out.println wander random plus question mark plus wander bias. And then I do not want to print that many, so we're going to do it by 10. And we're going to say wander bias could be between 12 and 18. Or 12 and 18. Cool, but it's going to be the new xy dot random. And we're going to do -1, 1, -1, 1. So it's not always going to call. We're going to set the speed back to 10. And we're also going to set we're going to do an wander random. Here's what we're going to do. If this dot velocity is equal to xy, if this dot velocity dot equals and we're going to go to xy, and it checks if it's equal to, and then we go to equals xy, other equals xy. Well, we'll override the object version. We're also going to do public boolean equal to xy, and we're going to do the same thing. And then also copy this and do it with a single number and do it with 2 ints. So int num, and int x, int y. So if it's equal to x and y, we're going to remove this. And then this has to be equal to if both are equal to num. So now we've created little equal to functions for x, y. Equal to, and then we're going to cut that off. So if the velocity is equal to 0, so both equal to 0, then wander random plus equals, we're going to add 8 to wander random. So they have more of a chance to move if they're standing still. Nice. And then in XY, whenever you call random, it just creates a new random, right? It creates a new random, cool. Which could be a problem. No, it looks okay. So he should not be standing still for long. This looks very similar to how I had it before, and I like this. So now we've created the wander function. Now we need to figure out what happens when it sees other things. When it sees other cells, it's not going to do much. But time to create other objects. New package com.main. Actually, we're going to refactor cell com.main.objects.object.cell. And now we're going to create a new package com.main.object. Wait, not package. We're going to do a new class in com.main.object and call it tree. And a new class called fruit. This is an oldie. Extends a game object. Now let's make sure that a game object isn't too complex for fruit. Implements ISShape, all the ISShape stuff, all the constructors, and you can constrain it. Okay. It's not too complex. We import, and then we add all the constructors. Now Cell is calling all the constructors. We're going to fold and collapse all. We're really only making it in XYs, but we might make it like that. I don't really care much for the dimension constructor or the XY and dimension structure. Oh, but fruits are always going to be the same size. We're going to create private final fruit size. It's not static. So final variables have that thing. I always forget. Wander bias. There we go. I'm going to collapse these again. So in fruit size, here we go. Private final fruit size equals 5. Fruits are going to be, actually 4. Fruits are going to be tiny. Private final int. Apologies. And in tree, we're going to do the same thing. Private final tree size. They're going to be equal to 40 by 40 or 50 by 50. Then we're going to create public tree, the constructor. It is going to get int x, int y. That's all it's going to get. Or it is going to get xy, xy. Which I guess the int of the digest is look at the xy first. We're going to call this new xy, x and y. We're going to implement xy's. We're going to call super xy, tree size, That refers to an instance field because has all specifically about the constructor. I'm gonna ignore that for a second to finish this up. We're gonna do shape dot circle and then color dot green. We're just gonna do color dot green for now. We'll create a custom field in a second. Now refer to an instance field size. Oh, it's an instance field. Private static final. Private static final fruit size. Then we're gonna call these same exact things in fruit, but we're gonna use fruit size instead of tree size, and we call this fruit instead of tree. Makes sense. There we go. We're gonna do shape square and color red. Wait, we have not created any. So we're going to create. We're going to spawn these objects. Starting cell count, tree count is going to equal 8. We're going to make 100 cells. Tree count, new object, tree. And that's all we need. Is a new XY. Wait. Oh, that's right. There we go. And then the parentheses, which you can shut off. And we have trees. Beautiful. This guy's just not moving. He really doesn't. Me for real? Wow. Is that it's not a problem because he's nearby something. They're all gonna stop around trees. Okay. That's alright. I'm okay with this.
I've been looking for shelter.
Right now,
Never feel safe.
we're gonna go to react.
It wasn't always this way.
Sensor is not empty. We're going to sensor dot filter. We're also going to go to sensor. We're going to go to the sense, and we are going to create a filter out as well. Filter out, and we're going to remove it. There we go. So back in cell, we want to filter out tree dot class. Filter out method in type sense is not applicable for us in this class. Well, it's about to be. Objects or from class. Final types cannot be further extended. Now we can do with classes as well, although...
I made a habit of never making promises that aren't easy to keep. And there you have it. But now I'm making one that is to keep you here with me. 'Cause every second that goes
Oh, and then create
is just a waste of time.
extend the game object.
With you, if home is where the heart is, then my home is where you are.
Type tree. Although we are just going to import objects.
So I'm taking you with me anywhere that I
So it should filter out trees.
for the rest of my life. I want
It
you
should move all of them. So they're not going to work.
There comes a time when I should have to leave. I could be
These guys are in clumps.
I'm taking you with me.
They're doing their thing. This dot target equals, just to make sure, new, that's why. Make sure it's working. We're going to create a new 0xy. So it should be stopping. If sensor is not empty. I'm going to create two of these guys. I'm going to, when I filter out. So they can using cell. System.out.println. Sensor.get all objects. Get sensor. Nothing. Now if I can make 20. This shouldn't take up too much. We had a couple ones that printed out cells, which we didn't want. So that's a problem in a sense. We get filter out from class. So some are outputting trees. Some should be outputting cells. So filter out is not working. Which I find frustrating.
I'm crawling out of my head for the first time in such a long time. These days,
So what we're gonna do
can't seem to throw it
is
away.
probably go to bed, right? Well, that would make sense.
With the black stripes, cherry wine, never could get rid of those stains.
It's not gonna extend nothing.
And I know I said I'd never go back, 'cause you already told me it's over, my world turned
And then we
cold.
gotta make sure that we bring this back.
From a hurt like that. Don't you care? Don't you know I can't go anywhere? And I know
They should be sensing each other. And some should be sensing trees. Oh, well, they're sensing cells. So I guess removing the extends helped it. Since everything is automatically going to predicate T. Well, we get it from a game object. What if we just get it from an object? Yeah, we know it's a game object. I figure that helps it run a little bit. Okay. So now we're gonna go back to cell. Make sure that you can. Oh, this dot target. This dot velocity. That's another issue of mine. We're not gonna print anything. So if they're near each other, they're gonna stop. Awesome. Okay. We're gonna create 200 of these babies. We're gonna run it again. And now they're all stopped when they approach each other. That's fine. So we're gonna get out all the trees because we don't need to worry much about trees. Although maybe I should add logic to where they try and stay around trees to, you know, eat. But I feel like that'd be too cheaty. Like, why even have them anywhere? at that point?
Devalue, discarded the cycle you've restarted.
I guess
You
we could
always
add
think
some
you're
sort of
above.
intelligence quotient or
Left
something.
here, heart torn, cold nights seem to always
Now
run from the
that we have trees,
'cause you split right
these
down
are
the
going to.
middle. You talk a
They're going to
lot,
implement a
but
thing.
you say nothing. Yeah, your mind is like a riddle.
So now I need to create. We're gonna create a new thread. One more new thread. I guess it could just be the spawner thread. Spawner thread I use a lot, but at the same time, apparently it's all super fast. But I am gonna go ahead. I guess it has to go through every single tree. I'm gonna create a new thread. That's going to be tree thread. Yeah. I'm gonna create this final tree thread. Thread. New tree thread. Three thread. And then we're gonna do oh, and then it needs to extends tick bound thread and unimplemented methods. Now the tick thread is going to automatically equal tick rate wherever the tick rate is from. Private int tick rate, so it is mutable. So the tick rate of trees is going to be a lot shorter. We're going to go into tick bound thread and create public void set rate int rate. This dot tick rate is new rate. Tree thread is going to call. It's going to call whatever is created public tree thread. It's going to do this dot set. What did I just call it? Set rate, yeah. Set rate. The new tick rate is going to be main dot tick rate divided by 10. So it is going to be a 10th of the normal tick rate, which I like. That way it's not doing stuff as often. And it is going to do main dot spawner dot get all objects. You could do get all trees, which I think I will. Okay, real quick, we are going to do full tree. Move that spot again.
Because the judge of you is someone I could never
import tree, and then when we go to spawn this together, we get all cells. Copy it out. Okay, has set tree.
Don't give up, it's not the end. There's hope for every fallen man. Pick themselves up when they think they can. Cause with every passing second comes a second chance. Oh, you stole so much from me, and there is nothing left to take. Save a hard-learned lesson on how to not make the same mistake. And you may be delirious, but that is something that will fade.
Trees. It's all trees. Everything's trees.
Oh, because a judge of you is
Did I
someone
miss
I
it?
could never be.
Trees.
is why you should thank the Lord that
Tree.
it is Him and it's not
Something.
me.
Tree.
But don't give up, it's not the
Public
end. There's
void
hope
spawn.
for every fallen man to pick themselves up when they think they can. Because with every passing second comes a second chance. Oh, don't give up, it's not the end. Get back on your feet again. Forgiveness can be given when you think it can. Because with every passing
Save
second
it. That
comes a
should be good.
second
Perfect.
chance.
Try grows. We can call a lot of things. First off, we're gonna do public,
Oh,
private,
oh.
void.
Take a good look at
Spawn.
yourself and know you've got yourself a ways to go.
Wait, count.
But difficult is not
For
impossible. You can take back
int
all
I is less
you
than
lost control.
int I.
Take a good look at
I is less than count.
yourself and see
I plus
that
plus.
you'll emerge eventually. As long as your
then
heart's
do
not too far gone from the only
int I
thing
equals 0.
that can save you from yourself.
It's not used. That's fine. I don't care. We're gonna do main dot spawner dot add object.
Forgiveness can be
New
given when you
fruit.
think it can. Cause with every passing second comes a second chance.
We're gonna do new xy, which should be the only thing we have to call, but it's gonna be xy dot. We're gonna call private xy
Touchdown, bags in the backseat.
spawn
Drive home,
range
the sunset's behind me. Small town, wonder if I'll
spawn
see her.
range
Oh, I wonder if I'll see her.
this dot spawn range.
Parties at where we had a
Spawn
first
range.
date. I got a dress, I
It's gonna
know
turn null at
we
first.
couldn't sleep. 'Cause I'm only here for
xy
the weekend.
xy
Pick
equals
it
new
up
xy
right where we left it. Let's go and paint the town like old
equals this dot get center.
Pretend that I never left for one night. 'Cause we never scared
So we basically want to create any range.
in the way you touch, the way you touch. Remember me just like this for
xy
old
dot
times.
random. We're basically going to get private static final int fruit range equals 50, which is going to be an additional 50. We're going to call it 40 actually, and I can play with these numbers later. So that's going to be the range. Random. This dot get position dot add fruit
Let's
range
go and paint the town like old
dot subtract because it's the minimal.
Pretend that I never left for one.
This dot and then I has shape. Didn't we create
Never scared to beat up
get
the
center, get size?
the way you touch, the way you touch.
We're not going to worry about
Remember
that.
me
Dot
just
add
like this for
this dot
time.
get pause dot add fruit range dot add this dot get size.
Take off back to the city. This trip felt like a sweet dream, and I'm already thinking about the next time. I'm already thinking about
from
the
dimension.
next time.
This dot get size dot add fruit range return xy spawn 10. Try this. Nice. I like it. I like it. I just don't want to create fruits. So that's the range of the fruits. But I don't want to create them here. And I almost want to create them in a circle, which would be cool. But that's a lot of math. Math that I can figure out later. To do make into circle range. There we go. And then we want to make sure later math is good. Yes. Oof, I do not want to deal with that. We're going to do. Oh, we can also create a clamp function in XY. Folding clamps all. Do we create a clamp here? So you have to clamp it to a certain minimum or to a certain maximum? I think so. It'll be after multiply but before negative. We're going to do public XY clamp min and public XY clamp max. We're going to create int clamp. Int clamp and return this. Return this. Clamping. Clamping on his beat. We are going to do this dot x equals math dot clamp. That's what I'm going to do. Clamps the value to max. So what did I do? Math dot minimum. So you want to clamp the minimum, meaning you don't want it to be any more than a certain amount. Oh, this might be some more later math, actually. We're going to leave these closed. Go back to tree. Make sure that if, we're going to do an if xy dot is within this dot get center tree size. All 3 AM math is later math. You're right about that. I might find a way to math this out later, but for now that's what the if is for. So if it is within the tree, we want to push it out of the tree. Oh, sounds like more trigonometry. Which I actually think, if I'm correct, is in XY already. Normalize as vector, so it hasn't normalized. Push it down with as Frank says, like Franklin. Wait, Benjamin Franklin? Franklin Roosevelt. Frank the Snake. Franklin the Turtle. Or Frank Webb, my lawyer. We are going to, if it is within, we want to get so distance, right? So is this going to be the distance 2 again? XY dot, no. Yeah, XY dot distance 2. This dot get center. And we're going to do system dot out dot print line for that. We're going to print it real quick. We're only going to create one fruit. Every tree. One fruit and then main dot kill. think I got rid of emergency, right? And now we're gonna use it. Perfect. 21.
So where that girl can break a heart, it's like a work of art. And this is the worst part.
But what to?
She knows it. She's so confident. She's what everybody wants, but nobody wants her to know that.
I wanna see it painted first.
So fall back on all of your
I want painted red.
passions and just learn to listen to
We'll
those
do.
that have more wisdom than you, and just stop putting
Kayla's
so
going to do
much all of this stuff.
S thread. We're gonna do L thread. Thread dot exit. What the? L thread dot
Waiting for you to be the one I'm
exit.
waiting for. Where that girl can turn her head, well, she is such a threat, but don't ever forget she knows it.
But it's not static.
She's got it all figured out. She won't let you down. She knows it.
It could all just be static.
I'm still waiting
But I think that'll change everything.
you to be the one I'm waiting for.
L thread dot exit. Dot stop. Well, stop isn't the thing anymore. Exit should be the correct thing. L thread dot. Oh, thank you. I do hope that is always the case. OSRS? Old school RuneScape. Yep. Yep, I knew that. I'm a genius. Painter thread. Do I want to override stuff on the painter thread? It'll be tick bound while running, while main dot running. Or private boolean always alive equals false by default, or always alive. This dot always alive. And then we're gonna do set always alive boolean is always alive. There we go. Painter thread is also going to call this dot set always alive to true. So now painter thread will always be true. And then it will run pthread dot exit. The method exit from the type that is not being verified. Painter thread specifically will be public void exit, which will this dot set always this dot. Is there no way to stop a thread now? Interrupt? P thread dot interrupt. Nope. P thread dot exit. Exit is gonna do this dot set always alive false. This dot print FPS is equal to false. Stop printing. I'm gonna call stop printing. There we go. So now we have three fruits only. We have more than 3 fruits. It's always a positive distance though. It's the only thing. Why is this? Why is growing fruit so complicated? We're gonna do. We're gonna system.printline a thing again. We can do xy.get distance 2. Or, and I got stuff as a vector here, right?
You can relax, my friend. Huh? I can tell you're getting nervous, so do yourself a service and try to relax, my friend. I'm fine, politics. Think of all that we have been through. We'll survive what
This
we
dot.
get into. I know that you're tired of the war and bloodshed. Tell me, is this how we're supposed to live? Look at how you grip your sword and I've said.
Should just be
Why should we
XY
take
dot.
when we could give? You can show a person that you trust them when you stop and lower
So this is the spawn
your
range. This is
guard. Can we
where
have
it's
a
spawning
chance
the
for
fruit.
some adjustment? Give it a try, it's not that hard. I'm telling you, this life is amazing when you greet it with open arms.
We're gonna do this, and we're just gonna print it back.
We're leading from the heart. No matter the place, we can light up the world. Here's
Oh.
how to start. Greet
Then
the
can I
world
offset it
with
by that much?
open arms. Greet the world with open arms.
Stay back!
My friend,
Here comes to
greet the world with open arms.
xy.add.
We're only here for food.
Whoops, what did I just do?
600 friends are waiting for us to show our faces. Stay back, I'm warning you. If we don't get back safely, my men will turn this place into blazes.
New
See?
xy.
This life is amazing when you greet
Alright.
it with open arms. Whatever we face, we'll be fine if we're leading from the heart. No matter the place, so we can light
We're not
up
gonna
the
main dot
world.
kill.
Here's how to start.
We're just gonna
Greet
grow
the world
fruits
with
all the
open
time.
arms. Greet the world with open arms.
Well, it didn't
My
exactly
friend,
work.
I wish that I could say that I agree.
Let's see the
But
range
look
that it
at the way this fruit is glowing and filled with glowing seeds. It took me a while to notice just what kind of fruit they eat. It's a lotus. It
Not exactly what I
controls your
want.
mind and never lets you free. That's what we
Let's
get
try
with
subtract.
open arms.
Lotus eaters, I'd like to show my friend that
There it
kindness
is.
brave. Could you tell me
Subtraction.
where there's other food to eat?
But I don't want it to go that far.
You're saying there's a cave where we could feast. And where do we sail to find this food-filled cave?
East that way.
Thank you.
How to lessen this value is the question.
This life is amazing when you greet it with open arms. I see in your face there's so much guilt inside your heart. So why not replace it and light up the world? Here's how to
We could divide it by
start.
2.
Greet the world with open arms. Greet the world with open arms.
Greet the world with open arms.
That should do it, right? Well. We could still keep all that instead of dividing by 2. Well, minus 10. Or we will do plus 10. Plus 100. Let's see how crazy that goes. What direction are we going in? Minus 100. Okay. We're subtracting it by the distance. It's a random position. Maybe we want to do this dot x minus xy dot x. And the same here. Maybe not. Oh, and then add. Excuse me. Okay, subtract, do the normal thing. And then take this whole xy dot and normalize as vector. Which is still created inside, but oh. We take this and we put it here. And then we want to take this whole thing and dot and multiply by xy dot get distance to this dot get center. We're gonna get math dot round. So that's a long. So we're just gonna add in xy. In xy multiply. I'm gonna add another one that allows doubles. We're doing this as needed. Whoops. Double. Well, that was easy.
I'm sorry that your heart broke when you lost control of who I would be with and when. Can't believe
And
it
divide it by
took a
2.
whole year to wonder why I'm here. Should have
Divided by 4.
this was how it would end. I can taste the salt on my lips from the tears that you made me cry. One day I hope you
This dot get center. Excuse me. Dot x.
one last goodbye and I'm going home.
This dot get center dot y. I think I'm just really bald.
I can feel the chill
I am insanely bald.
in the room. My fingers go numb when I'm right next to you. So here's your goodbye.
It creates it in a square, which I don't necessarily like.
On your own. 'Cause I'm done standing here.
Maybe I don't need to do all that.
So here's your feeling.
Subtract. Subtracted by the centers. Well, that's how I feel about that.
I bet you wondered if I miss you, reminisce you.
Subtract it like that.
Day that I left, but I hope your heart is healing and
And add.
dealing with all the reasons why you were such a mess. I
There
can
has to be a way. There has to be a way.
the tears that you made me cry. One day I hope you finally
And I'm pretty sure I'm probably just missing it, so. To do. Keep fruits from spawning in tree. And then in cell,
my fingers go numb when I'm right next to you. So here's your goodbye.
to do, eat fruits. Alright, with that, I am going to end the stream because, like Evan said, 3 a.m. math is later math. So, farewell for now. I might stream tomorrow, I might not. I hope so. Oh shoot, the music has been so loud this whole time. I forgot to turn down the music. I forgot to turn down the music after coding with John. Ah, that's on me. That's fully on me. Well, anyway, this is what it usually sounds like, Evan. It's usually not as bad. Very sorry about that. But, farewell for now. Hey, vibing's always good, man. Even if you can't hear me. Like about it is 3 a.m. I'm not very talkative now. Hopefully next stream doesn't last until 3 a.m. I just have to stop myself when I know that what I'm doing is impossible for me to solve because it's late. But yeah, until next time.